Good evening, guys. Welcome once more, and I know you are good this afternoon. Before I start, for those who have not subscribed to my YouTube channel, please I beg you to do so. And for those who have subscribed, I'll continue thanking you, and I'll request once more to give a thumbs up and share and give your comments as well. So today, I want to touch something on HIV and AIDS as far as its management is concerned. As you know, HIV is now a pandemic or a global disaster that gives different governments, including ours, a nightmare. But before we look at the management of HIV/AIDS, because I told you I'll majorly deal with the drugs managing certain diseases, I need to bring into your attention what HIV/AIDS is. HIV is a virus, and in full, it is human immunodeficiency virus. As its name suggests, it is the human virus. Neither does it infect animals, birds, plants, and other bacterial or other microorganisms. Although we remember that it originated from animal, the monkey, but in the monkey it was we can call it recessive or infective, or we can say monkeys are just carriers. As we know, an organism can be a carrier, like man are carriers of the human papilloma virus. So it was a carrier for the HIV, and in human it is infective and disastrous to human cells. So we have very many ways of getting HIV and AIDS, as we already know, but I will classify them into three, where first we have the exchange of body fluids, sharing sharp instruments, and we have mother to child during birth and breastfeeding. So before we look at the development of AIDS as a disease, because we know HIV is a virus causing AIDS, so the disease is AIDS, and HIV is a virus causing AIDS. So we have stages at which virus develop for it to become a disease in the body. We look at the replication stages. First, which is very important, is attachment and entry of HIV and virus. After contracting the virus, it will attach itself to the glycoprotein in the human cell, which are the GP120. The GP120 are the immune cells found on the T helper cells. T helper cells is one of the macrophages or the phagocytes that fight any foreign thing affecting the body. So it will attach to the GP120 present on the T helper cells, and from there it will also go up to the body receptors, and from there it will gain entry into the body cells. After it has entered into the body, what it will do, there will be what we call transcription. Transcription is where the enzyme transcriptase will change the viral RNA into DNA. What is the importance of this? Remember, virus cannot make its own energy. So in that case, it will be changed to DNA to help synthesize the early protein. This will help the virus to continue with the replication process, because the virus undergo mitotic cell division. After the transcription, there will be what you call the integration. The integration is what makes AIDS incurable. In that, the DNA of the viral will be inserted into the DNA strand of the human cell. So now they will look alike. So there will be no selection whether this one is a viral DNA and this one is a host DNA. So this is the point that makes AIDS very difficult to cure. Because remember, we said our drugs are very selective. They select non-human cells and they destroy the cells of the virus other than the cells of the human. So integration is what makes it incurable. 4 is transcription and translation. The translation and transcription is where the viral DNA is translated to RNA. This one is very interesting because at this point the virus will use the host cell protein to synthesize its energy. We said the virus cannot synthesize its own energy, but will always use the host cell to synthesize its energy. So it must be translated from the DNA to RNA. Remember how this virus is very, very stubborn. After the translation and transcription, there is what we call the assembly. At this point, the viral have developed and they have replicated in a high number, at which they get squeezed into the cell. So they will assemble and they will get released. So they will be released into the nearby cells. So at this point, the cells around the infected cell will be invaded by the virus, and at this point we said we have developed a disease called AIDS, acquired immunodeficiency syndrome. So before we look at the management, we look at the characteristics of virus. We said this one is a retroviral family. It is in the retroviral family, in that it is unicellular. Unicellular in summary means the virus undergoes self-division or mitotic self-division. It divides itself. Maybe if you want one cell, the cell will divide into 2, and the twos will divide each. They will be 4. The 4 will divide each, will 8, and this process is very, very fast. And 2, the virus cannot make its own energy. It uses the host to make energy. Okay. Now let us look at the management of AIDS. Management of AIDS is done at different levels. One will manage or will prevent the entry of the virus, and 2 will suppress the replication of the virus, because we cannot clear the virus in the body. So first, when we prevent the fusion, this is where we'll understand where the PrEP and the PEP come in. PrEP means pre-exposure prophylaxis, and PEP means post-exposure prophylaxis, and we look at the regimen for that. And then we have drugs that will prevent the replication of the virus. At that point, we have different classes of drugs. We have the nucleoside, and non-nucleoside. Non-nucleoside and nucleoside. Nucleoside drugs, they inhibit the transcription of RNA into DNA, and none also will do the same, though they lack nucleoside. So example of nucleoside reverse transcriptase, we have drugs like the tenofovir, we have lamivudine, we have abacavir, and we also have the sidovudine, which is normally used in the newborn. 2, we have non-nucleoside reverse transcriptase inhibitors. This also, as we said, inhibit the transcription of RNA to DNA. In this point, we have we may talk of nevirapine. Nevirapine is also very important in infants. Then we have integration inhibitors. They inhibit the integrase enzyme from inserting that DNA strand of the virus into the host cell DNA. At this point, we have what we call the dolutegravir and raltegravir. Then we have the fusion inhibitors. Fusion inhibitors, as we have said, they will prevent the entry of the cell, the viral cell, into the host cell. At this point, we have the PrEP and PEP. The best preference for PEP, we have PrEP is emitricitabine fumarate. This one we normally use in combination with tenofovir. And the PEP, the post-exposure prophylaxis, is where we have there we combine a nucleoside reverse transcriptase and fusion inhibitors, where we have tenofovir, lamivudine, and dolutegravir. In short form, we call it TDF, 3TC, DTG. So we have cases where you give PrEP, and the major case where we give PrEP, pre-exposure prophylaxis, is where we have the discordant couples. Discordant means one couple is HIV positive and the other one is HIV negative. So we prevent the other one from getting the virus by taking PrEP for life, or as much as they are still engaging in sexual activity, or as far as one is still exposed. Then we have the PEP. PEP we normally give when one is exposed, and we give it within 72 hours, and the drug is taken for 1 month or 28 days. So let us look at something on the regimen of antiretroviral drugs. Regimen where we have the first line regimen, the second line regimen, and the third line. Depending on the condition of the patient, we can give different types of regimen. The main factor we look at is the state of the visceral organs like the heart and the kidney, because most of the drugs are excreted through the kidney, and most of the drugs are pumped in the blood by the, so we need to devise a way on which we will not experience any problem with our visceral organs. So the first line regimen of the drug are we can give them in 3, but the most preferred according to the World Health Organization is tenofovir, lamivudine, and dolutegravir. So we will look at other exceptions. Other exceptions is where we can give tenofovir, lamivudine, and atasanavir. Though atasanavir is majorly used in the second line, we can use sidovudine, lamivudine, and atasanavir. So It has been, the study has revealed that the most preferred first line is tenofovir, lamivudine, and dolutegravir. And the second line is we include the tasanavir in combination with tenofovir and lamivudine, or sidovudine, lamivudine, and Kaletra. Kaletra is lopinavir, ritonavir. Then the third line is patient independent. This is where all the regimens have failed, so we just include other drugs alongside the first line or the second line. This is where we include the dolutegravir. We can include stavudine, we can include the darunavir. Then we can give almost more than 3 drugs, and in this point is normally affiliated or facilitated by the defaulters, the non-compliance. So they will give hard time in treatment. So remember, I said, and a given group which was very, very important is the protease inhibitor. The protease inhibitor, when virus is synthesizing the protein, it will develop very fast, or it will replicate very fast. So we majorly use the protease inhibitors to suppress the virus and prevent the synthesis of protein that will help in the replication of the virus. That one was the class that was remaining, and it is very important. The example is the tasanavir, ritonavir, and lopinavir, ritonavir. So another funny thing that you have realized, that all regimens contain lamivudine. Why is lamivudine very important? It's included in almost all regimens. We said that we have to protect the heart, and the main reason why we give lamivudine, it is hepatoprotector. It protects the heart against the side effects of other drugs. Like if you use tenofovir and dolutegravir, we include lamivudine to counteract any hepatotoxicity. So we call it hepatoprotector. So I want to look at the reason why we have the fixed dose combination. Why can't we use drugs individually? We have fixed dose combination where we have tenofovir, lamivudine, and dolutegravir. We have very many importance of this. First, we have what we call synergism, where one drug helps the other. One drug will help the other in that it will increase the bioavailability of the other. For example, in lopinavir, ritonavir is given in a low dose to increase the bioavailability of lopinavir. That one is synergism. 2, we are reducing the pill count, in that we cannot give individual drug for a patient. Same, we are giving 1 tenofovir, 1 lamivudine, and 1 dolutegravir. Instead, we combine them in 1 tablet and give it as a pill dose. That one will reduce the pill burden. And again, we are increasing, or we are enhancing the patient compliance. So when the patient is just taking 1 tablet, the patient will comply and be ready to take medicine. 2, we minimize resistance. Resistant in that when the patient is not complying, the patient is skipping doses because of high number of pills, that will lead to non-resistant. But now we are giving fixed dose combination to decrease cases of resistance. That reason, I will thank you very much, guys. I am very happy with you, and please, may you have a fantastic weekend. Thank you and welcome.